Wondered where your plastic goes after you toss it away? Is it recycled, reused, or does it silently drift into our oceans, choking life beneath the surface? Plastic waste, it's everywhere. From the bags we carry to the straws we sip from, it's the invisible footprint we leave behind every single day. Since 1950, global plastic production has skyrocketed from 2 million tons to over 450 million tons. That's not just growth, that's an explosion. And yet, only 9% of plastic waste is recycled globally. The rest? It ends up in landfills, incinerators, or worse, our oceans. Here in Australia, we discard 130 kilograms of plastic per person every year. 1 million tons of single-use plastic, gone, wasted, buried. Despite national recycling goals, only 13% of our plastic avoids landfill. So we have to ask, are we doing enough? Who's responsible? Consumers like us, addicted to convenience. Retailers and manufacturers, wrapping everything in layers of plastic. Governments, slow to act and weak in enforcement. Industries, construction, fashion, food, electronics, all playing their part. But pointing fingers won't clean our oceans. Why it matters. Every year, 11 million metric tons of plastic enter our oceans. By 2050, plastic could outweigh fish by mass. Let that sink in, more plastic than fish. Wildlife is choking. Microplastics are now found in soil, water, and even human blood. They cause lung inflammation, cellular damage, and are linked to cancer, infertility, and hormonal disruption.
Plastic waste has devastating environmental consequences. It disrupts ecosystems by contaminating soil, rivers, and oceans, where millions of tons of plastic accumulate each year. Wildlife often mistake plastic for food or become entangled in it, leading to injury or death. Microplastics, tiny fragments that result from the breakdown of larger items, are especially harmful, as they infiltrate the food chain and affect organisms at every level, including humans. Economically, plastic pollution imposes massive costs on governments, industries, and communities. Marine pollution alone is estimated to cost up to $2.5 trillion annually due to its impact on fisheries, aquaculture, and tourism. Coastal areas suffer from reduced tourist activity when beaches and waters are littered with waste, while municipalities spend billions on cleanup and waste management. Additionally, plastic-contaminated fish and seafood can reduce market value and threaten food security. Socially, the consequences of plastic waste are deeply inequitable. Marginalized communities often live near landfills or polluted waterways, exposing them to health risks from toxic chemicals and microplastics. These communities also face disruptions to their livelihoods, especially if they rely on fishing, farming, or tourism. The solution type we can use to minimize plastic waste is recycling, technological strategy. Proposed solution: Advanced Chemical Recycling, ACR. Advanced chemical recycling refers to processes that break down plastic waste into its original monomers or other useful chemicals, allowing it to be repurposed into new plastic products or alternative materials. Unlike traditional mechanical recycling, which is limited to clean, sorted plastics, ACR can handle mixed, contaminated, and hard-to-recycle plastics such as multi-layer packaging and colored plastics. Key technologies include pyrolysis, heating plastics in the absence of oxygen to produce synthetic oil or gas, which can be refined into new plastic. Gasification converts plastic waste into syngas, hydrogen and carbon monoxide, used for fuels or chemical feedstocks. Depolymerization breaks down polymers into monomers for reuse in new plastic production. Chemical recycling is backed by strong science and growing global momentum. According to CSIRO, Australia aims to cut plastic waste entering the environment by 80% by 2030, with this technology playing a central role. A 2024 review in sustainability shows it can recover up to 90% of plastic from mixed waste streams, far outperforming mechanical recycling. Pilot plants in Europe, the US, and Australia have already proven its scalability, with commercial expansion expected by 2026. Technologically, it's rated medium to high in readiness, with major companies like BASF and ExxonMobil investing heavily. While upfront costs are high, long-term savings and resource recovery make it economically viable. Environmentally, it reduces landfill use, cuts emissions compared to incineration and supports a circular economy, making it a powerful and feasible solution to our plastic crisis. Advanced chemical recycling is a game-changing solution to plastic waste. Unlike traditional methods, it can process contaminated and complex plastics, boosting global recycling rates beyond the current 10% and diverting millions of tons from landfills and oceans. It also cuts greenhouse gas emissions by up to 50% and supports a circular economy by turning waste into reusable materials. While challenges like high energy use and infrastructure costs exist, countries like Japan and Germany are proving that with the right policies and investment, the long-term environmental and economic benefits far outweigh the initial hurdle. I hope you found this video helpful and informative. Please like and subscribe for more videos like this. For now, goodbye Pookies.